Control flow. Now we get into the fun stuff. So far in our programs, every line of code was executed at some point. Control flow statements allow us to have parts of code which will be executed only if some Boolean condition is satisfied. If we think of our program as a road, we can think of control flow as various branches, and we can pick our path depending on some condition. For example, we will buy eggs only if their price is less than some value. Or if it is raining, we will bring an umbrella. Else, we will bring sunglasses. So written pseudocode, these two examples will look like this. If egg price is less than wanted price, buy eggs. If it's raining, bring umbrella. Else, bring sunglasses. Nim syntax is very similar, as you'll see below. If statement. An if statement, as shown above, is the simplest way to branch our program. The nim syntax for writing the statement is if, we give it some condition, we have that little colon, and then indented block what happens if the condition is met. The condition must be of type Boolean, either a Boolean variable or a relational and or logical expression. All lines following the if line, which are indented two spaces, make the same block and will be executed only if the condition is true. So if statement can be nested. An example, inside one if block there can be another if statement, etc. Okay, makes sense. So let's try something. Let's get rid of this exercise. And we'll do if, I don't know, 1 is less than 2, echo math works. Okay, so if we'll save it and run it, you get math works. Awesome. So what's next? So what I wanted to say, because they said that it needs to be true or false. In C languages and many other languages, I could also define something, let's say we have a variable is true. And we'll say true, right? If we'll replace that, save it, we run it, math works. Awesome. So what if I'm gonna turn it into 1? That's integer. Okay, it doesn't like it. We actually need to say is 1 or is larger than 0. So it's good to know that in nim, this actually needs to be either true or false. It doesn't try to pretend that 0 is false and everything else is true. Or that string is true while empty string is not true. That's hint for JavaScript, for example. Okay, good. I'm happy to see that. It's explicit. And we can nest things, right? We have let A be C, and if A is less than B, we can echo it. And if 10 times A is less than B, not only that, it's much more. So we can nest our if statements, one inside the other, because we have 2 indentation all over here, while this one has extra 2, okay? The same thing goes here, and the same thing goes here. But this is an example where we're also having multiple instructions. They have the same indentation, therefore they all belong to that specific if statement. And we can do something complex where we use our AND operator. Cool. Yeah, it just shows that, it will skip some things because it's false, so it won't show it. But I guess we can assume that this is, basic programming, so you don't have to worry. Okay. Else follows after an if block and allows us to have a branch of code which will be executed when the condition and the if statement is not true. Okay, that's classic too. So if this is true, this will be executed, but if this is not true, this one will be instead. Same thing goes here. So this way we can handle both cases. Okay, and then we have elif. Instead of else if, we have elif, short for else if, and it enables us to chain multiple if statements together. The program tests every statement until it finds one which is true. After that, all further statements are ignored. Okay, so we can basically check if it's this, if not, maybe if this, if not, maybe if this, and if none of those, it'll print that. Cool, very basic. Let's move to more interesting things. A case statement is another way to only choose one of multiple possible paths. Similar to the if statement with multiple elifs, a case statement, however, doesn't take multiple Boolean conditions, but rather any value with distinct states and a path for each possible value. I guess each possible value is a hint here. Code written with an if-elif block looks like this. If it's 5, 5. Else, if it's 7 or 10 or whatever else. It's can be written with case. So this is like a switch statement in many other programming languages. We do case and the x, so we're checking what the x is. So we have case of 5, do this. Case of 7, do this. Case of 10, do this. And if none were matching x, we print the else. So theoretically, you have what? 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Here you have 9 lines of code because you need to add that one. So you might think, it's more lines of code. Why would I use that? But at the same time, look, you don't have to repeat those crazy characters non-stop every damn time. You can just have simple, readable, okay, I'm checking for X, all those numbers, and default case. Awesome. Unlike the if statement, case statement must cover all possible cases. If one is not interested in some of those cases, else discard can be used. Okay, so this is something that many people like, and it's slowly coming to different languages that have pattern matching and etc. Basically what it means that if we wouldn't have this else here, the compiler will be unhappy, right? Let's try it. So if we'll place it here, and right now we don't have X, so let's say let X equal 8, okay? If we'll save it, run it, we'll get that unknown number because there was no case for it. If we put it to 7, we'll get 7 printed as expected. 7, there we go. So that's good. But if we'll remove this else case, suddenly, hey, not all cases are covered. So what this does, it basically protects us from the situations where we skip the number, or I presume we could have enumerations or some other possibilities in the future. Therefore, if let's say we have a set of 5 possible values that can be assigned to X and we cover them all, we'll be happy. But if at some point in the future we added one more possible value and we forgot that somewhere in our code base we have case over that, compiler will notice that and hey, you had that one spot where you missed to check for that. And this way we will, we won't have that weird bug that happens from time to time. It will be just covered from scratch. So I'm very happy to see that. That's a feature that a lot of developers are looking for nowadays. So me too. So I'm very happy about that. And in case you know that you don't want to do anything here, instead of, how do I make it empty? Because I presume if I will do that, save, yep, we have invalid indentation. If we have no indentation, what's going to happen? Invalid indentation, it expects something here, but there's nothing. So that's why we have this discard. We can just do, hey, discard it. This way we explicitly said that, hey, there's nothing happening here. No reason to complain. We handled it that way because we need it that way. So that's good too. Hey, if we can do else discard here, can we just do that? Oh, we can. There we go. That's much shorter. Cool. Okay. So we're switching over a character. Why? So we can switch over characters to see what character it is. And if non-selected, we'll just discard it. That's very nice to see. Okay. So we can also use multiple values for each branch if the same action should happen for more than one value. So we have our I equals 7, and we case over I. So we have case of 0, we do something. Case of 1 or 2, or 3 or 5 or 7 or 9 is odd. Those cases are even, and else we have too large. That's awesome. We can just enumerate those. I'll be happy. We don't need to do something that some other language with a switch statement. It wouldn't allow you to write something like that. You will need to do of 1 and then have of 3, and you just keep going with 5 and 7 and 9, right? That's what you would need to write. And then you have that, and you need to remember to, hey, I need to break the thing. So suddenly your whole thing is overly complicated. Here is nice and clear, right? Really easy to read. You can, if it's short, you can even do that if you want. And bam, you have something that's concise, really easy to grasp. I really like it. Okay, I'm excited about switch statements. So loops are another control flow construct, which allow us to run some parts of code multiple times. In this chapter, we will meet 2 kinds of loops. For loop, run a known number of times, or a while loop, run as long as some condition is satisfied. Okay, that's simple enough. For loop. Syntax for a for loop is for a loop variable and iterable. Okay, a loop body. So we can say that we iterate over a list of something, and here we're gonna get each item. Here we can operate on those items by using that variable. Awesome. Traditionally, I is often used as a loop variable name, but any other name can be used. That variable will be available only inside the loop. Once the loop has finished, the value of the variable is discarded. The iterable is any object we can iterate through of the types already mentioned. Strings are iterable objects. More iterable types will be introduced in the next chapter. So all lines in a loop body are executed at every loop, which allows us to efficiently write repeating parts of code. If we want to iterate through a range of integer numbers in nim, the syntax for the iterable is start ... finish, where start and finish are numbers. So iterate through all the numbers between start and finish, including both start and finish. For the default range iterable, start needs to be smaller than finish. Okay, if we want to iterate until a number, not including it, we can use the ... and less than. Okay, I like it. So we can say for iterate from numbers from 5 to 9, including 5 and 9. We can echo each number in it. Awesome. And then we can, I guess this will be to just insert the empty line. And then we can have the same iteration, but in this case, because this extra symbol is here, we iterate through numbers 5, 6, 7, 8, but not 9, because less than 9. Okay, this is what usually programming languages we're doing, but I definitely prefer those inclusive ones. That's awesome. All right, there we go. This goes to 9, while this goes only to 8. Simple enough. If we want to iterate through a range of numbers with a step size different than 1, COUNTUP is used. With COUNTUP, we define the starting value, the stopping value included in the range, and the step size. Oh, awesome. So we can iterate over from 0 to 16, where we increase over 4. So it will be 0, 4, 8, 12, 16, because 16 is included, and that's it. And we just print those numbers. So there you go. That's simple. I like that it's built into the language. You know, whenever you need something like that, it's like, oh, I need to write that function, or in JavaScript world will be, oh, I need to find a library that does that for me. Built in the language, easy to remember, awesome. I wonder if there's also countdown or something. To iterate through a range of numbers where the start is larger than finish, a similar function called countdown is used. There we go. Even if we're counting down, the step size must be positive. Okay, so when we count down 4 to 0, if we skip the number, we'll iterate over over all of them. Well, here we iterate 2 down, so we don't use -2, which is 2, and this knows to go down. All right, yep, makes sense. So string is an iterable. We can use a for loop to iterate through each character of the string. Awesome. This kind of iteration is sometimes called for each loop. Yeah, okay. So we have a word, alphabet, and for each letter in word, I guess it's for each so that you can read it nicely. So for each letter in word, so we get the word and we'll do something over each character, and that something will be to print it. So we print 1 character per line. Awesome. If we also need to have an iteration counter starting from 0, we can achieve that by using, again, for. Then we define a counter variable and a loop variable with the comma in the middle, and an iterator. Okay, this is very practical if you want to iterate through one iterable and simultaneously access another iterable at the same offset. Okay, so we have for I letter in words. So we, again, iterate over that word. For every character, we do something. So we define a letter, but before that, we define this I, so this will be an index of it. So it will be 0, 1, 2, 3, 4. And we print letter, that index number is, and that. So we go, letter 0 is A, letter 1, 2, 3, 4, 5, 7, and we have that for that. So this way, let's say we have that word and we have another word, we can probably just print out, use that index to get characters of the other word or some other list, or, you know, this allows us to iterate over many things at the same time. Okay, I really like that it's available for any kind of iterator, because there were too many times where I needed to write like a little for, I need to keep track of some extra variable in there to remember, oh, I need to increase it, and it's another point where you could introduce, you know, bugs or into your program. You know, most of the time you will notice that there's something wrong, and oh, of course I forgot about that. But again, it's another 1, 2, 5, sometimes an hour lost, because, you know, there are some programs that you write or you run it instantly and you see that something's wrong, but sometimes, you know, you have elaborate setup and it takes you an hour between you executing the code, seeing that there's a problem, finding the problem, rebuilding the whole program, you know, posting it somewhere and re-executing, and, you know, you just lost an hour because, oh, I forgot to increase an I at the end of the loop. And, you know, saves you time, it's easy to read, love it. Okay, let's go to the while loop. While loops are similar to if statements, but they keep executing their block of code as long as the condition remains true. They are used when we don't know in advance how many times the loop will run. We must make sure the loop will terminate at some point and not become an infinite loop. That's true. This is, the for loop. We already tell it that, hey, go through everything in the word, or go through the range between here and there. So it will run at a specific time, and the compiler takes care for us to stop the loop at some point because, we reached the end. With the while loop, we need to be careful because we set the condition. We have to specify when the change happens that, the loop is gone. We should stop it. So we declare a variable a equals 1, and we do while a times a is less than 10, then we execute that code. So if you imagine that here we have 1 times 1 is 1, so 1 is less than 10. So if that code inside the loop won't be changing a, it will basically run forever, and it will never stop. It will look like your computer hung, or in this case, we'll just keep printing that a is 1, a is 1, a is 1. That's why here we need to remember deadline, increase a. And increase is used to increment a. This is to increment a by 1. This is the same as writing a equals a plus 1, or a plus equals 1. Okay, so we have also plus equals assignment. Cool. So we have simple, very easy to read, increase 1. Okay, I guess they're not mentioning a++, so that isn't available, maybe? I guess we'll learn. And this way, as a increases, it'll be 1 times 1 is 1. That's less than 10. Okay, it's 1. Increase a. So a suddenly becomes 2. 2 times 2 is 4. Still less than 10. Print 2. Increase, we have 3. 3 times 3 is 9. Still less than that. Then we have 4. 4 times 4 is 16. And that's larger than 10. And that's like, okay. It's time to stop the loop, and the program, instead of executing what's inside, will just skip after it, which in this case is the line echo. Final value of a is, in this case, will be 4. So if I'll take that code, run it, there we go. 1, 2, 3, and the final value is 4. Perfect. Okay. So break and continue. The break statement is used to prematurely exit from a loop, usually if some condition is met. In the next example, if there were no if statements with break in it, the loop would continue to run and print until I becomes 1000. With the break statement, when I becomes 3, we immediately exit the loop before printing the value of I. Let's see. We define a variable I. It can change because we have var here. So I is 1, while I is less than 1000. So, okay, it's just 1. And then we check. And this is the inside of our loop. So if I is 3, then we break. But it's not, it's 1. So we print 1 and increment I. So 2 is less. Nope, print 2, increment 3. So while I is less than 1000, correct. If I is 3, we break it, and break basically finds the first loop and like, okay, you're done. It immediately goes after the loop. It doesn't even bother checking it anymore. It just jumps after the loop. Cool. The continue statement starts the next iteration of a loop immediately, without executing the remaining lines of the current iteration. Notice how 3 and 6 are missing from the output of the following code. So if we go for a range between 1 and 8, and we want to print every single one of them, but if I is 3 or 6, we continue. So we basically, the moment we see this, we instantly jump to next iteration. Bam. In this case, it will go to the next thing and run again. You could also use continue with while loop. If we would do if I equals 3 and do continue, we would just skip printing and incrementing the 3. And we would just go straight up here, and I would be still 3. So we go back here and continue, go up and up and up and up, and we will just be stuck here forever. Not even printing anything. So, in other words, continue starts iteration from scratch. So basically, when computer sees continue, it goes back to the beginning of the loop, including checking the condition, or in case of for loops, going over to the next item, while break just moves it out of the loop. Just skip the whole thing and finish the loop. Okay. We've got exercises. Collat's conjecture is a popular mathematical problem with simple rules. First, pick a number. If it is odd, multiply it by 3 and add 1. If it is even, divide it by 2. Repeat this procedure until you arrive at 1. Okay, so let's just copy it and do that. So pick an integer as a mutable value and create a loop which will print every step of the callout's conjecture. Okay, that should be simple enough. Okay, so let's solve this problem. It should be relatively simple. So first pick a number. In our case, they are asking us for mutable variable. Okay, so we'll be basically modifying it. Okay, so we do variable. Let's call it number. And let's pick a number for now. 80, why not? It's a number. If it's odd, multiply by 3 and add 1. If it is even, divide it by 2 and repeat this procedure until we arrive at 1. We do something until something happens, so we want our while loop. Until we arrive at 1. So while the number isn't 1, we'll be doing whatever needs to happen in our loop. So in this case, in this loop, we first check if it's odd. Okay, so let's do if number mod 2. So if we check if it's divisible by 2, that will tell us if it's odd or not. So if it's odd, that means it won't be divisible by 2. It will return 1, the modulus. So if that's the case, we want to basically specify that multiply it by 3 and add 1. Okay, so we do number is number times 3 plus 1. And because this is multiplying, it executes first. But for practice, for nice practice, I like to explicitly wrap it in parentheses to say that, hey, make sure you run this first and then add 1. You know, it won't make a difference for the compiler, but you as a reader of somebody else's code, you don't have to think like, especially in more complicated things like, oh, I need to multiply first. I need to, which goes first? Or am I working with, you know, in the future, you might have a job where you deal with 3 different programming languages and suddenly you have to think like, wait, I'm in this repository, means I'm using this language. Did this language respect those different operator orders or not? And in parentheses, you don't have to think, you just work faster. So if this happens, we just do that and continue. We just move to another iteration. We check if it's 1. But if that didn't happen, we can do if-else, elif, and we check if it's even, we divide it by 2. So we just do else then, because we checked if it's uneven, if it's odd. So the other option is it's even. So we just do else, and if it's else, divide it by 2. So number equals number, and we div 2. We're dealing only with integers, so I presume that we won't do only integer division here. They give us a hint, right? Use div for division. Okay, yeah, let's just do that. So we use div for division, and we do continue. So as far as we know, we just repeat it until we arrive at 1. And the only thing is that they ask us to print every step of the callout's conjecture. So we'll print every step. So let's look at it. We have only those 2 cases. It's either odd or not. We can even say, we can specify a variable here. Let is odd, and this will be this, okay? So if it's odd, do this. If it's not, do that. A bit easier to read. But because we know that we have only those 2 cases, we can actually, and we would need to do, hey, echo, and we need to echo the number, but they did it in a nice way where they just added arrows in between. So we can literally grab it and we can just say, hey, put this here, print this out. We just need to make sure that we start with a number. So we do echo number, and then we'll be adding that. So we can echo this, and then we can, top of me missing the B, I can do the other one. So that will work, but I personally see a problem here. We're having to write this twice. What's the point? Then we have continue twice. We can let it basically do this, where if it's odd, it will do that. And only if it wasn't odd, it will go here. So that means the code that was after it will be executed always after one of those. So we can just echo here and remove the continue because that's the end of the loop. So we'll start going. And at the end, after the loop, we'll remove the indentation here and we can do echo finished. So let's try to run it, see if it works. So for 80, we go to 40, 20, 10, 5, 16, 8, 4, 2, 1, finished. There we go. Problem solved. Next, create an immutable variable containing your full name. Write a for loop which will iterate through that string and print only the vowels. Use case statement with multiple values per branch. Okay, that's simple. So let's go back to our code. This one will be much simpler. So create immutable variable contain your full name. So let name is Benedict. There we go. Then write a for loop, which will iterate through that string and print only the vowels. So we do for loop. So for letter in name, that's all we need to do to iterate over all the characters. Compiler already hints us letter is a character, and we'll print only the vowels. So we can do the case of letters, all right? And we'll have case of A. And let's say we have the case of A, then we just do echo letter, right? And if that's not the case, else we discard. We don't want to do anything when we don't have anything else to, we are supposed to print only the vowels. So I could do this and then off E and also echo letter. I could go on like that, no problem. But they give us a hint. Use case statement with multiple values per branch. So in this case, we have only 2 branches. One where we're writing something and one when we're not writing something. So that's it. So A, E, I, O, or U. That's it. Why doesn't like it? Oh, because we need this. And that should be it. It should print out E, U, E. So let's get rid of our previous code because it just clogs everything. And save it and run it. E, U, E. That's it. I guess in theory, I should worry about there being capital letters or not. So I could add A and E, I, O, and we have the last one, U. This will suddenly handle other things. Let's say something like an Uber's surname. There we go. And when we run that, now we include our vowels that are capital letters too. And hey, not pretty, but if we wanted to use if statement instead of case statement here, we would need to write something like if letter is A, right? Or letter is E, or, and you see how it suddenly begins to be really lengthy. So it's really nice. I really like that. Saves a lot of time and confusion. I like it. Okay, next. FizzBuzz is a kids game sometimes used to test basic programming knowledge. We count numbers from 1 upwards. If a number is divisible by 3, replace it with fizz. If it's divisible by 5, replace it with buzz. And if number is divisible by 15, both 3 and 5, replace it with FizzBuzz. First few rounds would look like this. Create a program which will print first 30 rounds of FizzBuzz. Yep, beware of the order of this divisibility tests. Exactly. So I actually must say that I never wrote FizzBuzz myself. I read that it's so many times it's like a simple interview question for some reason. Seems a bit simple for an interview question, but sure, let's do that. We get our thing here. What we need to do, fizz, buzz, and if it's both, do that. And first few rounds would look like this. We don't care. And we need to print 30 rounds of FizzBuzz, and we have the hint, beware of the order. So we know that we need to do a specific 30 rounds. So that tells me instantly we have a specific number. We do 4. So let's do I for that number off, and we can use the, we start with 1, right? From 1 upwards. So 1 to 30. We include that 30. Okay. And it's an error type. What the hell? Do we need spaces here? I don't know. We'll see. For now, I assume it's correct. So if the number is divisible by 3, replace it with fizz. If something else, do something else. And if something else, do something else. So again, I feel like this would be a good example of a case statement. So case I, and we have case of it's being divisible by 3. So we take the I mod 3 equals 0. It's divisible by 3, right? If that's the case, we print echo fizz. Then doesn't like something. Ah, look at that. Cannot evaluate a compile time. So we found the first limitation, that the case statement works only with compiled things. So that means we need to switch it to if. So if I mod 3 is 0, we echo fizz. Else if we have the 5, this will be 5, replace it with buzz. So I mod 5 equals 0, echo buzz. And then if I is mod 15, we will echo FizzBuzz. And then we had the case when there is nothing else. So if it's the thing, then we just echo the number, which will be here. So I'll run it right now, but it will already be wrong. What is wrong here? Or in. There we go. So let's run it, but I already know that this will be wrong. And we've got 1, 2, fizz, 4, buzz, fizz, fizz, and then we got to 15. It's just fizz. So that's where was the hint. What the hint was. Beware of the order of divisibility tests, because the if statements will go from the top and try one by one. So we want to check for 15, but if we check for 15, 3 will go through, because whatever's 15 divisible by 15 will be divisible by 3 and 5. That means we actually need to do this statement first. Okay, so we do the fizz buzz and then elif, and I would say the 5. I just want to check then, like, this is the larger number that's being checked for division. I don't have an example in my head right now because everything else would be by 15. So I guess those two don't matter, but that's the case here. We just need to move them around, order them properly, and now we should get a proper order of things, I assume. Let's check for 7. So, okay, fizz buzz. 1, 2, fizz, 4, buzz, fizz, 7. 1, 2, fizz, 4, buzz, fizz, 7. There we go. And for number 15, we got the fizz buzz. So we're good. That was simple. I guess it's for testing like really basic knowledge. Oh wow, that page doesn't like scrolling. And we've got the last exercise, and after that we have new chapter, and we're already talking for 2 hours and 10 minutes, so I'll just do this one and we'll be finished. So in the previous exercises, you have converted inches to centimeters and vice versa. Create a conversion table with multiple values. For example, the table might look like this. Okay, sure, let's grab it as an example and let's code it. Let's add our example here. Okay. This will be our table. Their table looked nicer. I guess I need to paste it like this. Nope, doesn't work. There we go. For now, I'll ignore and I won't worry about spacing. That will be a lot of if statements. I just don't feel like doing it right now. It's something relatively simple to do. It's just, we'll see how we go. So I presume we'll have a list of values to convert. Let's say that our values. Okay, we'll do that later. Let's do it like that. We'll iterate over the values in inches and print them out in centimeters. So let's do a for loop, and this will be inches in, and we say from 1 to 30, okay? And now we're iterating over those inches, so we need to calculate how many centimeters that is. So we do let cm for centimeters, inches, divided by 2.54. So that suddenly will be unhappy because we have a float and we have that. So let's just do it as I, and we'll just make a variable let inches, and this will be float of I. So we have our inches as a float. We declare centimeters also as a float, and now we can print the table. So for the first thing, we need to print those 2 lines. So we can just do echo and give it that line. Then we can go and print this line. Echo, bam. And from there, we'll be just assembling those. So the simplistic way here would be to just do echo. We can do inches, then we'll print 1.0, 4.0, 7.0. So maybe for that, we'll actually use the I. So we print I, after which we just print a space, pipe, space. And after that, we're gonna print the cm for centimeter. I presume this will show some long names. I mean, a lot of characters. I don't feel like going through documentation to find how to format it nicely. That's for later. We're just learning loops for now. So if I will run this thing, what is going to happen? We've got our table, inches, centimeters, and we have that. So let's say that we actually want to make it like nicely aligned, like they did it here. So the simplest way here, in the way that we know right now, is to say, hey, if this is less than 10, add 3 spaces. If it's less than 100, add 2 spaces. And in other cases, add something else. So we can, I guess, calculate that relatively easily. So let's say that those spaces here, we'll just do spaces, and then we add the pipe. So let's do var spaces, and this will be our triple space, and then we do case I. Oh no, because here we're checking for larger, lesser. So if I is larger than, so like, let's just do 1. 1 will be for like the thousands. If I is less than 10, spaces is 3. And else if I is less than 100, spaces is just 2 spaces. And for everything else, the spaces will be just a single space that we declared before. And this way, that value should be inserted here, and hopefully we're gonna get a nicely formatted table. There it is. Perfect. And we have from inches to centimeters. Not really. I should multiply them rather than divide. There we go. Multiply. And run it again. And oh, we suddenly got nicer values. Other than this weird one here. And this is what the floating point numbers do. Sometimes, even though you do 26 times 2.54, which should be exactly 66.04, there was some little, mishap that the closest value to 66.04 that was possible to represent was this, with that extra little wiggle room there, like a little bit more. So yeah, that's the thing. But hey, that worked. Looks great. So this way we finish the chapter of control flow and loops, and we have just a few more things done. We are way more than past the half of the tutorial.